Hey, this is Michelle Kittner from the Gulfport School District, and in today's video, we're going to continue talking about proportional relationship problems. This is the second video in a two-part series, and by the end of this video, you should be able to set up and solve multi-step problems involving percents. The standard for this video is 7.RP.3. The vocabulary that we are discussing in this whole unit is listed here, but the only ones we're going to talk about in this video are percent, percent change, percent increase, percent decrease, and percent error. Remember, a percent is the number of parts per 100. It's an equivalent ratio where the second number is 100 and the top number is the percent, or the first number is the percent. The percent change is just a ratio that compares the amount of change to the original amount. A percent increase is the percent is a quantity increases from the original amount. So if a price goes up, it's the percent of the original that it went up. It's the percent change when it's an increase. A percent decrease is the percent a quantity decreases from the original amount. So if an amount decreases, it's the percent that it decreased. Percent error is the ratio that describes how far an estimate is from the actual amount. So what percent were you off by? So here's percent change. It asks, when you find percent change, you want to ask what percent of the original is represented by the change. So let's say Jose scored 5 touchdowns in his first football season. He scored 7 touchdowns in his second football season. What was the percent change in the number of touchdowns he scored? So in his original, he scored 1, 2, 3, 4, 5 touchdowns. And then in the second season, he scored those 5 and 2 more. So it changed by 2. So let's see, if the 5, we want to talk about the original. We're talking about always talking about the percent of the original. So if the 5 is 100%, how much is each of these blocks representing? It's representing 20. So this is 20%, 20%, 20%, 20%, and 20%. Down here, they're exactly the same. There's 20% here and 20% here. Each block represents 20%. It also represents 1 touchdown, but I'm more concerned about the percents right now. And so X sits right here at 20 plus 20. It sits right here at 40%. Now this one was easy to draw with a diagram, but not all of them are going to be that easy. So we want to make sure we understand how to do it with math. And how we're going to do that is we're going to take the amount of change over the original amount that equals the percent change. But the way we're going to set it up is we're going to set it up as a proportion. A proportion, remember, is 2 equal ratios, or 2 equivalent ratios. So we have the amount of change over the original amount equals the percent over 100. And then we have 3 of those. We'll solve for the missing piece. All right, we're going to set it up as a proportion and solve for the missing piece. Then we're going to ask ourselves, well, was that a percent increase or a percent decrease? Jose scored 5 touchdowns in his first football season. In his second season, he scored 7 touchdowns. What was the percent change in the number of touchdowns he scored? Was it a percent increase or a percent decrease? So let's set up our proportion. How much is the amount of change? Well, let's look. How do we find the amount of change? We can find it by subtracting over the original amount. The original amount is the first amount, and he first scored 5 touchdowns, equals some number, we don't know that percent, always over 100. Okay, so the first thing we've got to do is simplify a little bit here and subtract. So we have 2 over 5 equals X over 100. Okay, remember we want to isolate the variable. There's 2 ways you could do it. You could ask yourself, okay, what did I do to 5 to get to 100, I multiply by 20. So I multiply the 2 by 20 as well to get x equals 40%. The other way to look at this is we have 2 over 5 equals x over 100. I want to isolate the x. I want to get it by itself. Remember with algebra, what we learned in 6th grade is we want to get that variable by itself, and we use inverse operations. Well, x is being divided by 100, so we want to multiply the whole thing by 100, this piece by 100, and then we want to multiply this piece by the same thing, because whatever you do to one side, you've got to do to the other side. So we have 200 over 5 equals 100x over 100. Well, these 100s cancel down to 1. 200 divided by 5 is 40% is x. And did this increase or decrease? Well, he went from 5 to 7. He went up. He increased. So it's a 40% increase. Okay, let's look at another one. The arts department is selling candles to raise money for a trip. The candles sell for $12 each. After 2 weeks, the price decreases by 25%. What's the new price of the candle? Okay, so we need to set up our proportion. We know that this is going to be 100. We know that the second number on the over here is going to be the original amount of 12. Okay, and the other piece that we know is this 25%. Now, we know that this is going to decrease. Let's just find this missing piece here. Okay, so again, we want to isolate the variable. We want to get it by itself. So we can look here and we can say x is being divided by 12, so I can multiply it by 12 to get it to be 1x. But whatever I do to one side, I've got to do the same thing to the other side. So I'm left with 12x over 12 equals 25 times 12 is 300 over 100. These cancel to 1. And 12 divided by 12 is 1. So we have x equals 300 divided by 100 is 3. Now this tells us that our decrease is 3. This answers this piece right here. The amount of change is 3. Does that answer the question? It does not. It asks us what's the new price of the candle. So we have to take the original amount, subtract the 3, the decrease, to get to 9. The new price of the candle is going to be $9. Okay, percent error, it's almost exactly the same, except now instead of having the original amount for the second number in the first ratio, we're going to have the actual amount. So the local candy store is having a contest to see who can guess the number of jelly beans in a jar. The person who is closest wins a $20 gift certificate for candy. Adrian thinks that there are 300 jelly beans in the jar. John thinks there are 450 jelly beans in the jar. There are actually 400 jelly beans in the jar. Who has the lowest percent error? Okay, let's set it up as a proportion. So let's find their error first. So we know that Adrian guessed 300. There are 400. She guessed 300. Okay, that's how we find our amount of error over the actual amount of 400 equals, we don't know the percent, always over 100. Okay, let's set up Jose's. Jose guessed that there were 450. And there were actually 400, so we subtract to find the amount of error over the actual amount of 400 equals, we don't know the percent, so x over 100. All right, you guys seeing how we set these up? It's just subtracting put it over the actual, equals the percent over 100. Okay, now we just solve for the part that's missing. So let's simplify this. We have 100 over 400 equals x over 100. All right, we got to isolate the variable. X and 100, x is being divided by 100. So if we multiply this piece by 100, it uses inverse operations to isolate that variable. Whatever we do to one side, got to do the same thing to the other side. Okay, 100 times 100 is 10,000 over 400 equals x. And let's see. 10,000 divided by 400 is 25. So here, Adrian has a 25% error. Jose, we subtract, we get 50 over 400 equals x over 100. Isolate the variable. X is being divided by 100, so we want to multiply it by 100. Whatever we do to one side, we've got to do to the other side. Okay, 50 times 100 is 5,000 over 400 equals x. 100x over 100. Um, 5,000 over 400. So 5,000 divided by 400 is 12.5. So we have, I'm going to come up here because we're running out of space. 12.5, 100, these cancel to 1, equals x. So Jose is off by 12.5%. So we have Adrian at 25% and Jose at 12.5%. So we answer the question. Who has the lower percent error? Jose has the lower percent error. Okay, just remember that you are going to find the difference. It's the difference over the actual amount or the original amount equals the percent. And to find the percent, it's x or the percent over 100.